to talk about the topological space. So topological space is defined by a set of points along with a set of neighborhood in which every point must satisfy three axioms. So let me explain what I mean. Topological space. Topological space defined by a set of point. Let's call X as a set. And point, how many point? Can have like infinite number of point, but let's say X has A, B, C. Let's say X is a set. X is a three element, A, B, and C. So there are three element, cardinality is 3. The power set of X, which should be 2 raised to n, and that would be 1, 2, 3. So 2 raised to 3, so is 8. So the power set of X is 8. So topological space is defined by a set of point. X is a set, and X is a three element, A, B, and C. Along with a set of neighborhood. Let's call n as a set of neighborhood. Then n must be a subset of X. A set of neighborhood in which every single point has to satisfy three axioms. Satisfy three axioms. Three axioms, so that if it satisfies three axioms, then you can call it a topological space. But before give you three axioms, maybe I can give you three axioms. Axiom number one. Axiom number one is pretty simple. Axiom number one said the empty set, the empty set and X must be in tau. Okay, so when we write X, we can replace X by all the point in the X, all the element in the X. So instead of X, I can write A, B, C. So X must be in the tau. Number two, the union of all the subset must be in the tau. The union of all the set must be in the tau. So this is called all the index. This belongs to all the index. The union of all the index must be in the tau. Number three, the intersection of all the set must be in tau. So U1, U2, UN if it isn't tau, then U1, U2 intersection UN must be in the tau. So let me give you an example. Empty set and X. Is this a topology? Yes, it is a topology because it satisfies all three axioms. Why it satisfies all three axioms? Does it satisfy this one? Yes. Does it satisfy this one? Yes. Does it satisfy this one? Yes. Example number tau, and tau is in power set. Is this a topology? Yes. So power set, let's talk about the power set. Power set, if X is, say, X has a 3 element, then the power set of X has to be 2n, and that has to be 2, 1, 2, 3, has to be 8. And how is that? As we explained before, that the empty set must be in the set. So the empty set. So if the first one is empty set, what is the second one? Second one we can write A, B, and C. And then we can write AB, BC, and CA. And what left? We can write ABC. So 1, 2, 3, 4, 5, 6, 7, 8. So the power set of set which has a 3 element is this one. X is ABC, and then the tau is empty set AB, BC, ABC. Is this a topology? No, this is not a topology. Because does it satisfy the first condition? Yes, it satisfies first condition. Because it has an empty space, empty set, and it has the tau itself. The tau itself. The set itself. The set itself. Does it satisfy the second one, the union? The union of all the small set? No, it does not. For example, let's call this one P. Let's call this one Q. So P union Q. So P has AB, union Q has BC. All right. So what that's supposed to be? Oh no, intersection. Okay, this is supposed to be AB. Yeah. So the second one is satisfy the second one. Is satisfy the union. It does not satisfy, however, the third condition. How? Let's call this one P, this one Q. So P intersection Q. So P is AB, intersection BC. All right. So what is the intersection of P and Q? The intersection of P and Q is B. Intersection of P and Q is B. However, B is not in the tau. That's why this is not a topological space. However, this one is a topological space, and this one is a topological space. So once again, what is a topological space? Topological space is defined by a set of point. Let's call X be a set, and let's say we had 3 elements in the set, along with a set of neighborhood, in which every single point in the neighborhood must satisfy 3 axioms to be topological space. The first one is very simple. The first one is the empty set, and the X must be in the tau. The second one is the union of all the set must be in the tau. The third one is the intersection of all the set must be in the tau. So hopefully you understand it.